All right, now I'm going to go over a couple of problems that we went over last week. The start of whatever chapter we on, and I think it's chapter 6. So we'll pull up a couple of those. And I know that 2 or 3 people was not here. And I know probably half of y'all wasn't listening. So that's another reason I'm going over a couple of them. And hopefully, since he has my debit card, I hope he will be back. I only put $25 in there, so let's see. I don't know if we did one. Did we do negative 1.13? We are. We're going to do. I'm going to make sure. Did we do that one? What? You don't think you were here that day? Yeah, that might be a prerequisite to knowing if we did this one. If we were here. If you were here. We did? All right, go ahead and look at this one. And for those that can't see and sit in the back of the room, they want to know, what is the blue area? Find the blue area. In this case, you're given a z-score, and that means you need to find the area. It's equal to the right-hand side. What is the right-hand side equal to? How do you find the right-hand side area?
You look at the
greater.
1 minus the what? Y'all are a failure. It's in your notes because I give you that.
Wait, not on the right side you add.
1 minus the left-hand side.
There you go. Yeah, that's what I meant. We'll go over 2 of the easy problems, and then we'll move into one that you might have to think a little bit. So negative 1.13. Well, you go to your handy-dandy A2 table. Which takes, 5 or 6 seconds to print out. Pull up Google. Triola. 12th edition. A2. Table 4. There it is. We're looking up negative 1.13. So are you going to look on the negative z-scores or the positive? You're going to look on the negative. So negative 1 point, I done forgot it. 1 what? 1.13, yes. Negative 1.10123. 0.1292. 0.1292 is this area right here. So 0.1292 is that area. So if you want the right hand side, that's going to be 0.86 or 7, sorry. 0.8. Somebody check my math. Yes, no, maybe. Is that correct? All right, so you got an 87% probability over here. Or, I'm sorry, a 0.87 probability. Can't say percent. 87% chance. Okay? So that's that one. Again, that's one of the easy ones. You'll have 5,000 or 6,000 of those on the test. No, you'll probably have 2 or 3. Of course, somebody will miss them. But next one. I wanted to do 2 easy ones, and we'll do this one. Z is equal to 0.13. And that is a positive z-score. So you get the second page. And that'd be 0.13. So 0.1, 0, 1, 2, 3, 0.5517. So that area here is 0.5517.
Can you do it without having to draw that on?
Can you what?
Can you figure it out without, can you do it without having to draw that?
Well, let's see. The first thing what's the first thing I told you to do when you do these problems?
Well, you told us to draw that out.
Okay, well then my question, I want to ask you a question. If I said that the first thing you need to do is draw this out, what would that do to answer your question?
Yeah, what's that when you draw this out?
And the reason is, these are not going to be the easy ones. I mean, these are the easy ones. You're going to get some that are not going to be so easy. And we're going to go into those today. And then you're going to get some in the next section that are totally different from these. So it's a good habit to get into to draw them. Okay? Good habit. And no, you don't have to do it for these because these are pretty simple. On a scale from 1 to 10, these are 1s. So anyway, that's a 0.55 probability. And is that true, common sense wise? Yes, because what is this line right here, even though it's crooked? That's the mean, which is at 0, and that is 50%, right? So anything to the right of that line would be more than 50, and that's 55. So common sense wise, yes, it does fit. All right, those are the type problems we went over the last time you were here, whatever day that was. And now, what we're going to go over today? Well, we're going to finish up this section. But before I do any problems in this section, I want to talk about a couple of scenarios. Let's say that you are in Anderson. It's supposed to orient itself, but it didn't. Sorry. Not really on screen anyway. Let's say you're in Anderson. And you got 2 destinations to go to. Let's say this is Greenville. And this is Spartanburg. And you know that the distance from Anderson to Spartanburg, we'll say it's wherever you're going. You might be on the west end of Anderson. You may be going to the east end of Anderson, going to the west end of Spartanburg. So it all depends. Let's say 75 miles. Okay? And you know that the distance from Anderson to Greenville is about 35 miles. So if I ask you what the distance from Greenville to Spartanburg is, what would you do? You would subtract what? You would subtract the smaller distance from the what? From the larger distance. And that would be 75 minus 35. Now, a lot of you say, well, what's this got to do with the problem that we're going to be doing today? Well, the problems, and you got to think in this context. If you have a problem like, well, I thought we were already going there. There we go. A while ago I clicked on one and it was already there. There we go. Go ahead and write that one down. I mean, you don't have to write word for word. You can just, basically, this is what you're looking for right here. The key word here is between. So take that scenario that I just gave you, which is Greenville to Spartanburg, or Anderson to Spartanburg, and then Anderson to Greenville, and use that same reasoning with between 0.25 and 1.5. And that's why it's so important for you to draw a picture so you can actually see what you're looking for. And it might help you to shade also. Go ahead and work with it. And if you can't do it, just meditate. Because I know there's 3 people in here. There's ones that have no idea. Then there's one that remember a little bit about this out of high school probability. And then there's the ones that invented it. Okay? Okay, I hope y'all are not writing the whole thing because I told you not to. Just write down between 0.25 and 1.5. So, between 0.25 and 1.5. Well, what are we given? Are we given a z-score or are we given an area? We're given z-score, so that means we're going to be looking for areas. So I'm going to draw a picture. And 0.25 is going to be right about here. And what I'm going to do, I'm going to try to do this, so y'all bear with me. I will use a light color, like yellow. No, I didn't want to do that. All right, everybody with me? All right, and 1.5, for those that are listening, 1.5, we know this is 1, and this is 2, so 1.5 would be here. And I'm going to use that green color. I hope this works. Yeah, it's going to work, I think. I wanted it to, well, it's not going to work because, there we go. So, there's 1.5 right here. So if you take a look at those two areas, how can you relate that to the Anderson-Greenville-Spartanburg question? Very good. You take the area of the larger, subtract the area of the smaller. So when you're talking about between, you take the area of the larger minus the area of the smaller. So we look up 1.5 on our table. And that would be a positive z-score. And 1.5 comes out to be what? 0.9332? So the green comes to be 0.9332, or was it not point what? And then we're going to subtract, and I know you're not going to be able to see this yellow, but you'll just have to think you see it. I need to write it down as soon as I give it to you. 0.25 comes out to be 0.5987. 0.9587. That's not 0.95. What is it? 5987. Subtract those two. What do you get? Equals 0.33. Did you say 45?
Yes, sir.
And that represents that area right there. Now you see why you need to draw a picture sometimes, because to understand it, you need to draw a picture. If you don't draw a picture, you're not going to understand, one, how to find it, and then, even if you do find out how to find it, if you don't draw a picture, you're not understanding what the answer is. Question? All right, let's try nerd. I don't know which one we just did, but all right, y'all try this one. And don't draw, you don't have to write the whole thing down. Between negative 2.11 and 3.91. I'll write it on the board. Oops. Between negative 2.11 and 3.91. Y'all seen them yet? Or? Yeah, I don't. He might have locked them down. I don't know. 25 biscuits at one time. I don't know.
How many kids in your class? So there's gonna be 3 left over. So,
So they go into my next class.
well, you know, I just don't know. I don't think you don't even know as well. Y'all rough with that, but they're still seeing like that. Guess what? I'll have to move that.
Miss White, have you had this class in high school before? Yeah. I just wondered. I'm sorry. I will pull up. The 3.91 is going to be off the chart. And they have and for those, go ahead and be quiet for me. I appreciate it. If you look at 3.91, it'll be off the chart. And it says 3.50 and up is 0.99999. Hmm?
Priority 1 message coming in on secured channel.
And negative 2.11, which is on your handy dandy negative Z-score. Negative 2.11 is 2.1 and 0 and 1 is 0.0174. Well, can you have a negative area? A negative area is like a negative distance. It does not exist. If you travel from Anderson to Atlanta, you travel 225 miles. If you travel from Atlanta to Anderson, is that negative 225 miles? How many times you see negative 225 miles on a sign on the interstate? You never see it. Is that him? What?
She's going to the bathroom.
No, he probably is going to have to wait a few minutes. All right. So, anybody got a problem with that one? It comes out to be what? What's the area? 0.9825. So that's not a problem. Just take the larger from and take the smaller from the larger. And that would be between, it'd be this one right here. .9825. Fantastic. And you feel good about yourself. All right, take a look at this one. Now you might have to read this one for those that are actually participating. A thermometer is randomly selected and tested. Draw a sketch and find the temperature reading corresponding to the 83rd percentile. Corresponding to the 83rd percentile. So let me ask you a question. What are they giving us? Are they giving us area or z-score? Good job. So you need to put 0.8300. Well, at least we know he's not a criminal. I hope. No, that's mine. He said he was going to get me one. Can he make it, or does we need to send somebody down to help him? Okay. All right. So, on this one, you're looking for z-score separating the 83rd percentile from the 17th percentile, basically. So 0.8300. Somebody tell me, is that a positive z-score or negative z-score? Why? Because it's past 50%. So 0.8300. And as I tell students, the best thing to do is act like that's $83. 83.00. Go over here and look up 8300. See if we can find an 8300. There is no 8300. It falls right in here. So what I tell students to do is think of it as $83. What's closer? 82.89? Well, 82.89, $82.89, that's 11 cents from $83, right? What's this one? $83.15, that's 15 cents more. So which one's closer? 82.89. So that would be 0.9, what? 0.95, thank you. Or, I'm sorry, the z-score is 0.95, thank you. Okay, just note, put the 3 bags out and just let them all fight for it. That's what I do. So all you picky sneakities, y'all better get up here and get what you want. That you're not allergic to everything. All the ones that don't give a rat's rear end, you just wait. Thank you for reminding me, because I don't. If you say something, I'll.
Thank you, Hubert.
You're welcome.
Thank you.
You're welcome.
Thank you.
You're welcome. Everybody, you're welcome. Okay. No, see me. Yeah, see me right after you get through. Right after we get through. So this one came out to be 0.83 would be way on the right. I guess it'd be this one. That would be, what did we say it was? Point what? 0.95. Well, I'll take them to my next class if nobody wants them. I mean, I know there's somebody in here not eating. There's always somebody. Well, I really don't want anything. Yeah, whatever.
Get some mayonnaise.
All right. Yes, ma'am. All right. So that's how you do Chapter 6.2. then what's the difference between 6.2 and 6.3? Well, here's the difference. In 6.2, your mean is 0. In 6.3, your mean is not 0. So I'm just going to show you a example, a simple example. There's an example. What are you doing?
I got paper towels.
They didn't give you any napkins. Where's the condiments? And they didn't give you any napkins. Boy, I tell you, the IQ intelligence, the IQ level is just high at these places.
Hey, trust me.
Give them a bag of condiments, but don't give them any napkins.
Trust me. They were doing good just to give us all the food.
All right, what's the Z-score on this one? $115? What's the Z-score on this one? Yeah, let's just put a decimal in there. It's 115, but that's not the Z-score. That is X. What? What'd y'all say? You can't see it? Yeah, I know. Well, you know, hold on. There. How's that? Is that better? All right, now read the question and write the question down.
Thank you, sir, for my only milk.
What'd you say?
Thank you for my only milk.
Oh, okay.
Yeah, shame, man.
Boy, that thing, boy.
We got skin. I was real tempted to take a sip of that Diet Coke.
Diet? Please don't tell me that's a Diet Coke.
You told me Diet Coke.
No, I don't drink Diet Coke.
You
Thank
said Diet. You said extra large Diet Coke.
No, I did not.
I feel real bad.
No, take it. Don't worry about it. Take it.
You don't want it?
I don't drink it. Dang old brain tumors in rats.
Brain tumors. Y'all want some of it? No, I know why. I didn't really.
All right.
Why? I swear you must have accidentally said it. So I was like, why did he want Diet Coke?
No, I don't drink diet drinks. Because they're really not good for you. The sweetener they use in it, it does cause bad things. And I didn't know this thing had a... Yeah, she really looks like she needs to. I say if she gets any wider, we're going to have to get a new door. All right. So, that was a joke, okay? That was a joke. I have to tell everybody that was a joke because you just don't want to know. So, what do? Quit? Because there's not a Z-score of 115 on your table. You got to find the Z-score, but you're not given a Z-score. You're given what? X. There you go, which is your Z-score formula. You actually listen in class? Dadgum. I'm not used to that. So,
It'd be one.
here is your mean and your standard deviation. So, Z-score is equal to X minus X bar over standard deviation,
115.
which is 115, thank you, minus 100 over 15,
1.
which is 1. Now, it's not always going to be an even number, but they're starting you off easy. And, of course, you go to 1 in your handy-dandy table. And 1.01, I'm sorry, 1.00 is 0.8413. So, your area for this 115 is whatever it was, I done forgot it, 0.8313. It's hard to write with a mouse. 8413. Now the problem don't come with these type problems. The problem comes when they start asking for the area between two different, what are these, IQ scores, or the area after greater than an IQ score, or then they give you the areas, and then they want you to tell what the IQ score is, and that's where it gets a little bit complicated for people. Okay. So let's try nerding. That's a good one. I'll blow it up for you. This is between.
So you subtract it?
We find the z-scores first.
But that's what I'm asking. Is the x the distance between?
Yeah.
Okay. Can you move it down a little bit so we can see the mean?
Okay, please work on the problem. 115, and the bottom is the two on the graph is 80 and 125.
I thought you couldn't have a negative number.
Said you can't have a negative area. Huh?
I was talking to them.
So change each one of them into a z-score, and that's going to be 125 minus 100 over 15, which is 25 over 15, which comes out to be 5 over 3, or something like that. Somebody help me. 25 be 5 over 3, which will be 1 and 2/3, which will be 1 and 1.67. Somebody help me out. And then 80 is going to be, it's going to negative z-score. 80 minus 100 is negative 20. And negative 20 over that would be negative 4/3. And then 1.33.
So you add those together?
No, you just find the areas and you subtract the areas. Just like we did in that previous problem. This is the Greenville-Spartanburg type problem. So find the area of, I have no idea what the z-scores are now. They just gone. 1.67 and negative 1.33. So go to your handy dandy table. 1.67, and that's why I count, because sometimes when I'm up here and this goes off, the top goes off, I just count. 1.6, that's 0, 1, 2, 3, 4, 5, 6, 7. 0.9525. So 0.9525. And then 1.33. Negative 1.33, 0, 1, 2, 3, 0.0918. And that's going to come out to be something. 95 cent minus 9 cent is what? 86 cents. Going to be 85 something. What is it? Or 86? What is it? 8607. My stomach's killing me. And that's your that's your area in the green. Now, for the silent calculator team members, those of you that have to live by the calculator, you can actually do this on the calculator. Go to second bars, normal CDF. So go to your second bars, normal CDF, and you can only put in z-scores. So, second bars, normal CDF, which is 2, and then type in, which way do we read? Left to right. So what in that last problem, what z-score came first?
0.925.
Well, from left to right. Well, yeah, negative 1.33. Negative 1.33. And then what was the other one? 1.67?
Yes.
Close parenthesis, enter. Now, I don't know if there's a way to do the area to find the z-score. I don't know. I'll have to look it up and research it. I don't know. But that's how you do it. Well, what if you not finding one between, Hubert? Well, for negative infinity, how do you type in negative infinity with these problems? Well, negative infinity would be negative 0.999 or negative 999,000. Positive infinity would be 999,000 or 999,999. 4 nines or 5 nines. 3 nines is about the lowest you want to go. So if you have a z-score of 0.84 and you want to find the area greater than 0.84, then you would type in second entry, and then you would put in over here, you would put 0.84, delete, and then what would I put in for positive infinity? 999, and hit enter. And that is the area to the right of 0.84. So your calculator will give you the area to the right, or the right-hand side. Yes, ma'am. Now that is a normal CDF. Okay, which calculator is that? Okay, well the mean on all the 6.1 questions is, or 6.2 is 0, and the standard deviation is 1. let's see, probably the normal PDF. Let me see if they give you that in 6.2. You'll have to look and see. I'll have to research it. I don't know if there's a way you can actually find the area, but okay, you can find the area by using inverse norm. So you need to, so if you wanted to find the area of 0.9, which is, the z-score corresponding to 0.9, you would hit, now that's 0.900, 90%. If they give you 90% and you need to find the z-score that represents the 90th percentile, you'll hit second bars, inverse norm, and I would assume 0.9000, I would assume. And there's your z-score. So you can do both. And we will start using the calculator as of today. We'll start using the calculator to do it, as well as doing it by hand. Okay? Because I could teach my 7-year-old how to use the calculator. You need to know what you're finding. Okay? All right, let's try nerd. Hello. Not many people know who says that.
Can you explain?
Who says hello? Who says that when they answer the phone? Hello. Medea. You ever watch Medea? Mr. Massey, you need to watch Medea. Everybody needs to watch Medea. You know why everybody needs to watch Medea? Because she's right half the time. Yes. No. All I know how to do is hello. That's all I know how to do. Hello. Oh, have y'all seen the latest commercial about the psychic line? Have y'all seen that? There's a 1-800 number you can call to learn about your future.
Of course there is.
I want to call them and say, what is the lottery numbers for tomorrow?
See what they have to say about that.
Oh, I can't predict that. Well, then you're a fraud. You should be sued. That's what I'll do. I'll sue them.
Get more.
And that way I could make $1 million real easy. No, that's for only the people that are stupid enough to put a large scalding hot coffee between their legs while they're driving.
Oh, yeah.
Y'all don't remember the McDonald's lawsuit? The DAD person that bought a large coffee and stuck it between their legs going down the road? And they had a wreck or something happened and they spilled, and they sued McDonald's. Yeah, something like that.
It's literally called
McDonald's were heating the coffee higher than other people.
I still, when you buy hot coffee, still, the whole point is, if you buy coffee and you're driving down the road, there is a chance that you're going to spill it. I mean, now did they spill it on her? Now, if they were handing it to her through the...
It was hotter than
It's going to be the normal crew tonight. I looked last night.
Well, it shouldn't have been that hot.
That's why she won.
Oh, okay, well, there's been probably more than that one. I still think it's ridiculous. I think it's just going after deep pockets. Oh, the one I'm talking about was like $1 million.
Well, the person the one I think you're talking about, they, whoever their lawyer pushed for more.
Yeah. That was about 10 years ago. All right. All right, y'all back with me? All right, do this one. They want to know, okay, is everybody going to be quiet or what? Do I have to turn the lights on and off or what? All right. This one says we got a standard deviation of 15, a mean of 100, and they want you to find the z-score, the x that separates the bottom 4% from the top 96%. So go to it. If I was you, I would draw a what? I would draw a picture. Shut up. All right, so they want to know, for those that are listening, the bottom 4%. Now, where is 4%, Hubert? Well, there's 2.5 right there. So 4% would be right in here, maybe. All right, there's your 4%. And we'll color that green. And then 96% is on this side. So you can either do an inverse norm of 96%, or you can do an inverse norm of what? 0.04%. Or you can do it by hand. But the whole point is you've got to change it back to an X because you're going to be given a z-score. So I don't care how you do it. So let's take our handy dandy calculator. Hit inverse entry. And what am I going to put in? Well, I'm going to put in 0.96. Is that what it wants? 0.96? And what's that z-score? Well, no, 0.04. Sorry, I did the wrong side. 0.04. It's just a negative, but you want to be consistent. You don't want to start thinking. There we go. Negative 1.75. So if you put negative 1.75 on the test, you're going to get it what? Wrong. Why? They didn't ask for the z-score. For those that are listening and paying attention. So, the z-score, the z-score is equal to x minus x bar. I suck at writing with the mouse. Over standard deviation.
That's 15. Oh, that's an F.
Okay? So, if you wanted to solve for x, what would it be? Well, I use the parameters for population when I do this, and that would be z is equal to x minus mu over standard deviation. And basically what you get is x is equal to Oz plus mu. Sigma times the z-score plus mu. If you solve it algebraically, you get Oz plus mu. Now, of course, it's not O, it's what? It's sigma, which is your standard deviation. So all you have to remember is whenever you want to find an x, you just plug it into Oz plus mu. So what would that be? Well, what's your sigma? 15. So that'd be 15 times your z-score. What was the z-score? So take your calculator, negative what?
1.75.
Negative 1.75 times 15 plus 100. And what do you get? 73.74. And that is your x. So remember, Oz plus mu. So there's only 2 in 6.3. there's only two formulas that you need to know. One is z-score is equal to x minus x bar over standard deviation. And then x is equal to Oz plus mu. And that's the Hubertism, Oz plus mu. All right, so y'all can work on 6.2 and 6.3 now. Wait a minute. I got to get the roll, people. I ain't kidding you. We got some rude people in here.
Always get what you want, or get what you need.